is Silapan Limbapapong, MC/7 number 2.
Hello, my name is Gavin Charit, MC/7 number 28.
Spectrum of light. The visible light spectrum is the section of the electromagnetic radiation spectrum that's visible to the human eye. It ranges in wavelengths from approximately 400 nanometers to 700 nanometers. It is known as the optical spectrum of light or the spectrum of white light.
Visible light on the EM spectrum. The visible light spectrum is a very small part of our giant electromagnetic spectrum. The EM spectrum consists of 7 different regions, including X-ray, infrared, and ultraviolet light. The electromagnetic waves that we can see are confined to this small area called the visible light region. This part of the spectrum is the range of light frequency to which the human eye is more sensitive. Visible light share many characteristics with the other EM wave because it too is a type of electromagnetic radiation. These sharp particles come from a variety of sources, like the sun, other stars, and the warm objects like books and animals. Any sort of EM radiation that we can see, like the light from the sun, is considered visible light. So other sources of visible light would be flame, red hot metal, and the glowing screen on your cell phone. Our ability to see everyday objects is due to the reflection of light from the surface of those objects. For example, the reason you can see your car in your driveway is because the sunlight is reflecting out of it.
Wavelength and color spectrum chart. The wavelength, which is related to frequency and energy of the light, determines the perceived color. The ranges of these different colors are listed in the table below. Some sources vary these ranges pretty drastically, and the boundaries of them are somewhat approximate as they blend into each other. The edges of the visible light spectrum blend into the ultraviolet and infrared levels of radiation. How white light is split into a rainbow of colors. Most light that we interact with is in the form of white light, which contains many or all of these wavelength ranges within them. Shining white light through a prism causes the wavelengths to blend at slightly different angles due to optical refraction. The resulting light is therefore split across the visible color spectrum. This is what causes a rainbow, with airborne water particles acting as the refractive medium. The order of wavelengths is in order of wavelengths, which can be remembered by mnemonic RGB for red, orange, yellow, green, blue, indigo, and violet. If you look closely at a rainbow of spectrum, you may notice that cyan also appears fairly distinctly between green and blue. It's worth noting most people can't distinguish indigo from blue or violet, so many color charts omit it entirely. By using special sources, refractors, and filters, you can get a narrow band of about 10 nanometers in wavelength that's considered monochromatic light. Lasers are special because they are the most consistent source of narrowly monochromatic light that we can achieve. Colors consisting of a single wavelength are called spectral colors or pure colors.
Color beyond the visible of spectrum. Some animals have a different visible range, often extending into the infrared range or ultraviolet. For example, we can see ultraviolet light, which is used by flowers to attract pollinators. Birds can also see ultraviolet light and have markings visible under a black light. Among humans, there is variation between how far into red and violet the eye can see. Most animals that can see ultraviolet can see infrared. Also, the human eye is red and distinguish many more colors than those of the spectrum. Purple and magenta are the main way of bridging the gap between red and violet. And saturated colors like pink and aqua are distinguishable. Colors like brown and tan are also perceived by people.